In this little episode, we want to derive the equation of a tangent at a given point on a circle. I've drawn a little diagram there of the circle. The center is A and its coordinates are h and k. R is its radius. So from what we've seen before, the tangent equation will be x minus h all squared plus y minus k all squared equals r squared. Since x1 and y1 lie on the circle, we can replace x and y by x1 and y1 to get the following fact: x1 minus h all squared plus y1 minus k all squared equals r squared. Now number that one, we'll be using that in just a moment. Now, the gradient of the line AT is the difference of the y coordinates, y1 minus k, divided by the difference of the x coordinates of the 2 points, x1 minus h. And so the gradient of PT is the negative reciprocal of that. If two lines are at right angles, then their gradients, the product of their gradients is minus 1. And so the gradient of PT is minus x1 minus h over y1 minus k. So the equation of PT, the equation of PT is y minus y1 equals the gradient x1 minus h over y1 minus k times x minus x1. So, multiplying up, getting rid of all the fractions, and rearranging, that will give us y minus y1 into y1 minus k equals x minus x1 into x1 minus h. And we'll call that equation number 2. So, slight mistake here. That should be plus, and that should be 0 because we've taken this term to the other side. Sorry for that little hitch, but I hope it isn't causing too much consternation. Anyway, we'll now add 1 and 2 together and factorize. So add 1 and 2 and factorize. And what do we get? We'll get y1 minus k, y minus y1 plus y1 minus k plus x1 minus h into x1 minus h plus x minus x1 equals r squared. That comes down to y1 minus k times y minus k plus x1 minus h times x minus h equals r squared. That's the result that we are after. Okay, so you can see that that is quite easily remembered if you go back and see that the equation of the original circle is x minus h squared plus y minus k squared equals r squared. And just rewrite, say that first bracket out twice, but replace one of the x's by x1, and similarly over here. And then you'll get this equation up here. So, we'll now just do a little example to illustrate that. So find an equation of the tangent to the circle x minus 2 squared plus y plus 5 squared equals 13 at the point 4 minus 2. It's easy to check that 4 minus 2 lies on the circle. So all we've got to do now is plug that into the formula, and what we'll get is 4 minus 2 times x minus 2 plus minus 2 plus 5 into y plus 5 equals 13, and that will quite easily simplify out to 2x plus 3y equals 2. And that concludes it. Thanks very much for listening again.